Hi everyone, this is Sangeeta working as Assistant Professor in IoT department. This session I'm going to discuss about Ethernet standard. We know that there are a lot of standards available for physical and data link layer. In this session, we're going to discuss about the physical layer standards, Ethernet. So the data link layer and physical layer both working together. This standard provides the specification for wired LAN technology. Okay, so the IEEE 802.3 is a project of Computer Society of IEEE. In the year 1985, it started. So the main focus of this one is to enable the communication among equipments from variety of manufacturers. So the project 802 is a way of specifying function of both physical layer and data link layer for major LAN protocols. The next will have that there are variety of standards and it's participating in data link layer, Ethernet, token ring, token bus, and etc. So this session we're going to discuss about standard Ethernet. The standard Ethernet is created in the year 1976 in that research center of Park, and it is, may have various generations also there. We will discuss it one by one. So here, there are four generations of standard Ethernet are there. First one, standard Ethernet, it supports 10 megabits per second. The next generation is fast Ethernet, it supports 100 megabits per second. After that, gigabit Ethernet, then 10 gigabit Ethernet will be used. So the variation is the bit transmission. Next, we'll have that the frame format of gigabit, the standard Ethernet. So the 10 megabits per second, it's supported by the standard Ethernet. It's following the frame format. Have the preamble field, start frame, delimited field, and source and destination address, and the type or length, and data will be added. Finally, the error detection code will be added. So, okay, the preamble bit is 56 bits of alternative zeros and ones, and the second is a start frame delimited. The bits will be 101010 and the destination and source address will be added. Then length will also added. Then the original data is included, and finally the error detection code will be used. So here the minimum and maximum frame length is 64 bytes to 1518 bytes. The source and destination address will be 48-bit MAC or LAN or Ethernet address. Next, we'll have in that 6 byte address, the first byte indicating the type of communication, either unicast or multicast or broadcast. So based on the first byte least significant bit, we can say this is the type of address. If it is a 0, we can say it is a unicast. If it is 1, we can say it is a multicast. If all bits of the first byte is 1, we can say it is a broadcast. So in this example, there are different type of destination address are given. The first byte is byte is 4A. The equivalent bit of the least significant bit of A is 1010. The least significant bit is 0. So we can say it as a unicast address. Then second one B, 47. 7, the equivalent bit is 0111 and the last bit is 1. So we can say it is a multicasting. Then third one is F. The first byte fully all sequence of ones. So it is a broadcast address. So based on the first byte least significant bit, we can say the type of address. Next, the category of standard Ethernet specify the following cables. There are three transmission mediums are there. Coaxial cable, fiber optic, twisted pair. Okay. So here 10 base 5. 10 is nothing is a 10 megabits per second and baseband signal will be used. 5 is a 500-meter length thickness of the cable. Then here the coaxial cable will be used. Then second one is 10 base 10 base 2. So here 10 is the 10 megabits per second baseband signal. 2 is that thing is length of the cable thickness. So thin coaxial cable will be used. The second one 10 base T is a twisted pair cable will be used. Unshielded twisted pair will be used. So it's mainly used in star topology. For 10 base F fiber optic cable will be used. It's also have been used in fiber optic cable. The encoding in both encoding and decoding in Ethernet will be Manchester encoding is used. So twisted pair of cables which connected and the data will be encoded and decoded by Manchester encoder. So the 10 base by implementation looks like this. The main cable like a bus topology is used. The thickness of the cable is very bigger one, so we cannot adjust it. We cannot like it doesn't have any flexibility to fold or adjustment. So the baseband signal will be used. The data rate support by is 10 megabits per second. The second one is 10 base 2. In the 10 base 2, the cable is 185 meter. The thick, thin coaxial cable will be used, so we can adjust it like a garden hose. Then here it's also support 10 megabits per second and baseband signal will be used. Then next category is like a pair of twisted pair cable will be used as like a landline telephone communication. So unshielded twisted pair will be used in 10 base T. And 10 base here, fiber optic cable, two pair of the fiber optic cable will be used. Then let's use like a star topology instead of half the switches will be used. So like why is the cables are used? These are all the various standards specified by a standard Ethernet. So medium is 10 base 5 thick coaxial cable. If it is 10 base 2 thin coaxial cable. If it is T unshielded twisted pair, then 10. If it is F, the fiber optic cable will be used. Two pair of fiber optic cable will be used. So in every encoding is the Manchester encoding and decoding is also Manchester decoding. So that's all about standard Ethernet. We will discuss the other generations in next class. Thank you.